The primary industries are at a stage where the introduction of automation is going to expand rapidly. The Agri-Engineering Group at the University of Waikato is embracing the opportunity to come up with solutions to a variety of primary sector issues.
Several years ago, we were contacted by a company, Arborgen, who had an issue with whole production, sort of where they were planting their cuttings for growing forestry seedlings. And so that, for us as engineers, that's a really interesting challenge. And so after some fourth-year students had developed a little prototype, which worked quite well, we then had Ben McGuinness, who's one of our graduates. He then undertook that as a project, and he developed a dibbling machine, which is like a computer-controlled machine that can drill holes for Arborgen, and that's been working down in Tokoroa now for about 4 years. At the moment, we're working in the forestry nurseries, which are nice and flat and are relatively controlled, but even that's a really harsh environment, because if you're harvesting seedlings on a really rainy, windy day in Tokoroa with the mud and rain, then the machine's got to cope with that, and that's far more difficult than harvesting goods into a controlled environment and then working with them. So it is very challenging. Okay, Ben, so how's it running at the moment?
Yeah, it's getting there, so all the belts are working well. This is for a forestry nursery, and they currently grow 6 million trees every year. And every year, all of those trees have to be pulled out of the ground. The soil has to be removed from the roots. The roots have to be cut to the right length and has to be graded to strict specification. So this is currently done by a team of 30 or 40 people. The idea is for this machine to do the job, or at least cut down that workforce to a manageable amount. So its current state will probably be run by 5 or 6 people instead of 30 or 40. To get that rate of 6 million trees every year, it has to harvest about 5 trees a second if you're going to harvest at the same rate that a human would in an 8-hour day.
Oh, we'll definitely get the times off this, easy.
So this will pull them out of the ground using a pair of rubber belts. Clean the soil off the roots using the rotary beater. It'll cut the roots, and then we're using machine vision to actually take images of different parts of the trees. So the stem, the height, and the roots, which is actually really important. And make a decision like a human would, say whether it's good or bad, and sort it accordingly. I've done a lot of the image processing. We've made a bunch of what we call dirty prototypes, so they're just kind of hacked together in the lab just to test out ideas. And this is the next iteration of the ideas that worked. So the next couple of weeks we'll look at taking it out into the field and testing it.
I think we're right on that tipping point of commercial viability, where people say, well, actually, I'm going to take this smart automated machine or this robotic machine to do this task because it's better than what the humans can do, plus you haven't got all the issues with trying to get labour, which is mostly imported from overseas. You'll need skilled operators, and that's another thing I really like about this, is that you're looking at upskilling people in this area for maintenance and for operation. So that you're sort of changing that work profile. I know that's more of a social context, but as an engineer, I really like that idea that you're just upskilling people, producing better equipment, and, and the value of people's jobs goes up. The other issue is that these machines that we developed can be exported as high-value equipment, and that adds a whole new layer of value that New Zealand can get out of it. So you get 2 bangs for your buck. You get a solution for New Zealand, and you also can have export services and machinery overseas. We feel really privileged that we're working with a really top team with Robotics Plus and Auckland University and Plant and Food on kiwi fruit harvesting, kiwi fruit pollination. We're also looking at apple harvesting for linear orchards, which is a new type of orchard being developed, and also trimming and possibly pollination with the new type of apple orchards. And that's really interesting work, and we've got a large team from Waikato. I think I counted up that since the last 3 years we've been working in this area, we've probably had about 20 Waikato engineering graduates and researchers and staff working on this. I think at the moment, across the primary sector, because of all the issues we discussed earlier about the labour shortages and cost, and also the need, for example, to reduce, for example, the use of herbicides, to be much more smart and controlled about how we deal with the environment in the primary industries, is that there's a lot more opportunity and drive to come up with more high-tech solutions for this. Plus, we've got lots of smart, young Kiwi engineers. You put them in the mix, and you can actually solve a lot of problems, which you couldn't do that long ago. It's sort of like, the perfect storm of technology. The issue with something like the dibbler, which is great for solving a particular problem, but we've still got to work on the commercialisation aspect of it. Is there more of a need for these types of machines around the world, for example? Could you build 30 dibblers? I wouldn't say of that particular one, but maybe the Mark II, where you've learned everything we've learned from it is incorporated in the second stage design, the Mark II, which then could become a product. We're not talking about mass production, but we're talking about small batch production, and then you can export them as high value products. We don't know, it hasn't been investigated, but that's something that we need to start looking at in New Zealand, is the solving a problem in New Zealand and then looking at the opportunity to develop that solution into something you could then export as a high value product. The pollination of kiwi fruit flowers is a very interesting area because of the two current ways it's done at the moment. One is like almost crop dusting, which is fast but very inefficient use of high value pollen. And the second one is with the Cambrian sprayer, where you're squirting flowers manually, and there's 30,000 flowers in one row. It's very accurate, but it's very poor use of labour, and mostly imported labour. So this new type of technology, new sort of graphics processing, and really smart algorithms for identifying where the flowers are, you can do them in real time. It's like a tipping point. You're suddenly going, well, you could now go down an orchard possibly at like 1 metre per second, which is pretty fast, identify flowers and spray them with pollen, dramatically reducing the pollen, but getting the rate up to where it's really a valued business. There's groups from Auckland University and Plant and Food Research who sort of deal with machine vision and the pollination, working with ourselves and Robotics Plus to make sure this works. So it's really much a collaborative New Zealand project.
This program was made with funding from New Zealand On Air.